welcome to The Explainer. Today, we're popping the hood on modern manufacturing. Look, if you've ever found yourself totally lost in the alphabet soup of supply chain acronyms, just staring blankly at a whiteboard full of three-letter words, wondering how on earth anything actually gets built, well, you're definitely not alone. Our goal today is to completely demystify manufacturing planning. We're going to focus specifically on the incredibly powerful, directly linked relationship between the master production schedule, the MPS, and material requirements planning, the MRP. Let's get right into it. I want you to picture a massive factory floor for a second. Imagine the absolute chaos if hundreds of workers and machines were just, guessing at what to build each day, or just crossing their fingers, hoping the exact right parts were sitting on the shelves. It'd be a total disaster, right? So how does a highly efficient factory know exactly what to buy and exactly when to buy it? Well, the secret lies in a foolproof, highly structured, top-down scheduling system that essentially acts as the brain of the entire operation. Okay, let's dive into this. Here's our roadmap for the explainer. Section 1 is the hierarchy of manufacturing planning. Section 2 will get MPS and MRP explained. Section 3 is step-by-step component planning. Section 4 will see it in action with a product day example. And finally, Section 5 is closing the feedback loop. All right, Section 1, the hierarchy of manufacturing planning. To really wrap your head around this, you kind of need to think of manufacturing planning as a top-down waterfall of data. One schedule directly powers the next in a super strict sequence. It starts at the very top with Step 1, Sales and Operations Planning, or S&OP. This is your big picture, strategic view of what the company actually wants to achieve overall. But obviously, you can't build physical products with just a high-level strategy. So S&OP passes the baton down to Step 2, Master Production Scheduling, the MPS. And then that schedule cascades down into Step 3, Material Requirements Planning, the MRP. That's your granular, boots-on-the-ground execution right there on the factory floor. Moving on to Section 2, MPS and MRP explained. Now, if you take away just one concept from this whole explainer, let it be the what versus which dynamic. The Master Production Schedule, our MPS, is the primary driver here. It dictates exactly what finished end products to make and exactly when to make them. It deals 100% with finished goods. On the flip side, the Material Requirements Planning System, the MRP, well, that's your detailed calculator. It takes that master schedule and figures out exactly which lower-level components, raw materials, and subassemblies are actually needed to make those finished goods a reality. Think of it like this. The MPS gives the orders, and the MRP figures out how to supply those orders. Which brings us to Section 3, Step-by-Step Component Planning. Now, what's really interesting about this slide is how these two systems actually hand off data to each other. Once the master schedule is authorized, it spits out quantified due dates and amounts for specific end items. These scheduled end item quantities become what we call gross requirements at the top level, or level 0. Basically, these gross requirements are the direct input that gets fed straight into the MRP system. And the second those gross requirements hit the MRP system, this really fascinating process kicks off called the bomb explosion. The MRP takes those top-level MPS requirements and essentially explodes or disaggregates them downward through the bill of materials. Think of the bill of materials, the BOM, as basically just the recipe of parts needed to build your end item. So by exploding the requirements through this recipe, the MRP calculates the exact net requirements for every single raw material you're going to need. Let's just log in this sequential flow really quick so we have it down. First, the MPS planned order releases dictate exactly when manufacturing for an end item has to start. Second, the MRP takes over, using that bill of materials as its guide. Third, those top-level releases immediately become the direct gross requirements for the components and raw materials at the very next level down. And finally, this whole calculated plan authorizes the work orders and aligns supplier timing. And hey, why does this actually matter? Well, without this precise alignment, suppliers wouldn't provide the right parts at the right time. Your factory would literally grind to a halt waiting for materials. Or, on the flip side, you'd bleed cash by overstocking parts you don't even need yet. Let's move to Section 4 and see how this builds. In action. Product A example. All right, imagine an organization is tasked with building Product A. This is our finished good, the end item. Now, the absolutely key constraint you need to remember here is that Product A has a manufacturing lead time of exactly 1 week. That just means from the moment you start putting it together, it takes 1 full week to be finished and ready to ship to the customer. So here is our master production schedule for end item A. As you can see, over a 4-week period, we've got a steady customer forecast of 100 units per week. Now pay super close attention to the timing here. Because we have that 1-week manufacturing lead time, to guarantee we have 100 units of product A received and ready in week 2, a planned order release absolutely has to be scheduled a full week prior, so in week 1. That means the factory has to officially begin assembling those 100 units of product A in week 1. Make sense? But remember, to even start assembly in week 1, all of your necessary components must already be sitting there ready on the shelf. And that brings us to our bill of materials multiplier. Our recipe says that every single unit of product A requires 2 units of component B. This single multiplier right here is the vital link connecting our big picture finished goods strategy to the actual raw material reality on the ground. And this is exactly where the linkage snaps perfectly into place. Just watch how beautifully the math works out here. The MRP system takes that MPS planned order release of product A from week 1, which remember was 100 units, and it multiplies it by the BOM quantity of 2 units. Boom. This calculation automatically populates the gross requirements row for component B with exactly 200 units in week 1, and it does the exact same thing for week 3. The MRP system will then take those 200 units, net them against whatever inventory is already available, and flawlessly calculate when the purchasing team needs to buy component B so it's ready for assembly. Literally no guessing involved, just perfect, cascaded mathematical alignment. So let's wrap this up with Section 5, closing the feedback loop. The crucial point we have to remember is that this beautifully linked system is not just static data. It operates in the real, sometimes messy world. Once the material plan is created, step 1 is executing that master schedule on the shop floor. But, stuff happens. Machines break down, suppliers run late, the usual headaches. That brings us to step 2, where shop floor control actually spots these inadequacies in materials or manufacturing capacity. And when that happens, step 3 immediately kicks in. Shop floor scheduling and controls start sending continuous warning signals backward in a loop. They feed right back into the MRP system to alert planners, hey, the overarching goals of the MPS might actually be in jeopardy. Which leaves us with a really critical question to ponder. What happens to the entire manufacturing system when the shop floor reality just doesn't match the master plan? Well, as we've seen today, because the MPS and MRP are just so incredibly tightly intertwined, where one's output is literally the other's input, any friction on the floor means the whole top-down system has to continuously adapt and recalibrate just to survive. It's essentially a living, breathing ecosystem of data. Thank you so much for joining me for this explainer, and definitely keep questioning how the things around you are built.